Hello friends, I Dr. Sarika Panwar welcome you all in the video lectures of machine learning. Today's topic of discussion is support vector machine. Support vector machines, as we all know that machine learning algorithms are classified into supervised learning algorithms and unsupervised machine learning algorithm. In supervised learning algorithm there can be classification problem or regression problem, and in unsupervised learning algorithm there is only clustering problem where we do the grouping of the data points. As far as classification is concerned, there are various algorithms available for classification task like support vector machine, discriminant analysis, naive Bayes, so nearest neighbors and neural networks. So support vector machine is one of the supervised machine algorithm which is used for the classification. It can be actually both employed for both classification and regression, but it is most commonly used for classification problem. And supervised machine learning algorithms are based on the idea of finding the hyperplane that best divides the data set into two classes. So here what we can see that there are two classes, blue class and yellow class, and we have to find the best hyperplane which will classify the available data points into two classes. So in this case we can observe that there are three hyperplanes which are classifying the data points into two classes, but we have to choose the optimal one. So what is hyperplane? Hyperplane is a line that linearly separates and classifies the set of data. Here there are n number of hyperplanes which can divide the data points into two classes, but we have to choose the optimal one. So data points should be as far away from the hyperplane as possible while still being on the correct side of it. And when new testing data is added, whatever side of the hyperplane it lands will decide the class that we assign to it. So this way we can say is the optimal hyperplane because the margin is maximum. What is the margin? That is the nearest data distance between the nearest data point from either of the category. The distance between the hyperplane, this hyperplane, and the nearest data point from either set is known as the margin. So here we can say that this is the margin and it should be maximum as far as possible. The goal is to choose a hyperplane with the greatest possible margin between the hyperplane and any point within the training set. So these we can say that these are the training sets because these data points are used for the training. So it will give a greater chance of new data being classified correctly. If the margin is maximum, it will give a greater chance of new data point being classified correctly. We know that we can choose the best optimal hyperplane if it is linearly separable data. So we can easily put a linear hyperplane between these two classes. But what about the case wherein the data points are linearly non-separable? Here we cannot put any linear line. Why? Because these data points are non-linear data points. These are not linearly separable. So such data points are called as linearly non-separable data points. So for such linearly non-separable data, simple linear line will not do. So in such case we have to use some tricks. So there are two methods for separating the separation of the linearly non-separable data points. One trick is soft margin and second is the kernel trick. So in soft margin what we can do, we try to find a line to separate but tolerate one or few misclassified dots. Like in this case we can see that this is linearly separable data points. Simple linear line, such linear line can easily separate such data points, but in this case what we can observe that these data points are linearly not separable. If we try to put such line in this case also, then it will misclassify this data point as a green data point. So for such case we can use the soft margin. So by using the soft margin method, what we will do, we can tolerate such one or few misclassified dot. So if we put such line, if we try to put such soft margin between these two classes, then we are tolerating some one or some few data points misclassified. So that is the soft margin method. Second is the kernel trick. So in kernel trick, what exactly we do? We find the non-linear decision boundary. That is the kernel trick. So basically in kernel trick, we classify a linearly non-separable data set. See, here we can observe that these data points are linearly non-separable. These data points are linearly non-separable. So for such cases, what we do, we use the kernel trick. So in kernel trick, what is done, this two-dimensional data set will be mapped to higher dimensional. Here in this case we can see that it is two-dimensional plane, and this two-dimensional plane data points are mapped into three-dimensional plane. We have seen here it is a 3D space, and in three-dimensional space we are mapping the two-dimensional data points. So with this, what we can do now, we can easily use this plane to separate the data points into green and blue category. So mapping of the data into higher dimension is called as the kerneling. So this is actually the kernel trick, wherein we map the data points into higher and higher dimensional spaces. So in this case we have observed that two-dimensional space data points are mapped into 3 dimensions. So if we do so, we can use this plane to separate these data points. So higher plane can no longer be a line. Here it can be a line. In the earlier case, what we have seen, that we can use the line in two-dimensional space, but if we map the data points into higher dimensional space, then it will not be a line, it will be a plane. So the data will continue to be mapped into higher and higher dimensions until hyperplane can be formed to segregate it. So that is the difference between the kernel trick and a soft margin. So there can be different types of kernel functions like Gaussian or RBF kernel function, linear kernel function, polynomial kernel function. In polynomial kernel function, it can be a kernel function of polynomial of degree 1, 2 or 3. So based on our application, we can choose any kernel function, and we can verify our result whether we are getting a good accuracy for the classification or not. So that is nothing but the SVM. If you like the content of the video, so please like the video and subscribe to my channel. Thank you very much.